That was an amazing conversation. In fact, I'll touch upon what Dr. Faiz Ahmed spoke about. The nails are everywhere, I can guarantee you that. The hammer is not just big enough at this point, to the point when he said there's not enough data available and we are actively working to fix that. And we'll speak more about that throughout the conversation. So my name is Arnie. I lead a team called the Cloud and the AI Innovation Team within AWS. And just so you know, everyone probably knows Amazon, right? You all shop at Amazon more than we probably should, but thank you for doing that. But Amazon is a big retail company made up of massive, one of the biggest supply chains in the world. We run a lot of robots. We have almost 1 million robots right now of various forms and shapes, 8 different types. And if you watch Prime Video, it's another big unit. If you use a Kindle, if you use Alexa, all these are different products. Now, underpinning all of this is the Amazon Cloud, also called AWS, and that's the group that we work in. And within that team, the team I lead is a global team of AI technologists. Our mission is really simple. We sit down with where the nails are. We work very closely with BMW and Siemens in Germany, massive financial services companies, massive telco companies. And what are they doing today? What are the pain points that are happening today? And how can we use AI to solve that? That's really our mission. And we start at home, right? I mean, Amazon is one of the biggest users of AI, biggest. Every time you log onto that page and the minute you even load up the Amazon.com page, roughly 100 algorithms, AI algorithms kick in. They know who you are. They know what you like. They want to know what to present. When you pick a product, when it says, hey, order in the next 4 minutes if you want it tomorrow night or tonight, how do you know that? There's a series of algorithms that run behind the scenes. So we know exactly which bin, which robot will pick it up, which truck will eventually deliver it for you. And we do that in less than 1 second because we have no patience. You want to know, right, when it's going to come at your doorstep. So AI is really everywhere. And I have a really fun job. Not only do I get to spend a lot of time with customers, I spend a lot of time with our research teams to shape where AWS is headed. So I spend a lot of time in Seattle and around the planet. And the team is pretty amazing. So we have a bunch of folks here from the team. So just take a note of their names. They'll be helping you with the workshops today. They are deep domain experts. Each and every one of them is probably speaking to at least 10 customers every week, maybe more, right? If you're an AI, you don't have time for a vacation really nowadays, right? So you just like back to back to back to back. But it's a ton of fun. This is how you learn. You speak to customers, and that's how you really learn, what's happening. So Mahendra is a name that Bruce had mentioned. He's been associated with this for a while. Justin was here last year as well. He was up late last night troubleshooting the workshop, so it all works smoothly for you. You'll run into 2 problems today. Number one is some second part of the workshop will get a little technical. We're at MIT. I think you guys will be okay, right? But the second problem we may face is GPUs, right? We hope that by the second half of this year, the compute problem will reduce, but we might run low on GPU capacity. So we run into issues like, hey, I'm throttling on tokens. This is basically our cloud saying, hey, slow down, right? We don't have as much capacity now to keep up with you. So because we have to do that to support, the global customer base. We have 2 new faces. Felix is here. Felix is local. He came from a whopping 6 minutes away. So we decided to pull Felix into the family here. And then finally, we have Tony, who joined this crew here as well, coming in from Nashville. And I'm really fortunate. I come to MIT fairly frequently. We have multiple collaborations. We fund a fair amount of MIT research. So if you go to sciencehub.mit.edu, that's Amazon that does a ton of collaboration with a variety of MIT professors. And I teach a class here as well. So I'm here once a quarter teaching AI for executives, class. I'm fortunate to be able to come back every single time I'm on my travels, right? So what we'll do today is a quick agenda here. So you already heard, an amazing conversation from Dr. Ahmed. I'll share a little bit about what's happening with AI. We'll do a model workshop. We'll show you a tool called Party Rock where you can play with the models a little bit. I'll come back and give you a 101 on what's happening with agents. They're everywhere. What are they? Like, why do people care about it? Do they work? Do they not work? What are the pros? What are the cons? We'll talk about that. We'll take it live. We'll do an embodied intelligence, which is basically embedding these large models and making robots work. So you can actually see a real robot controlled by a large model. And then we'll do a deep agentic workshop. You will all build agents today. Real agents, you'll build it, and you'll see how those agents work. We'll build probably 4 agents. They all work in conjunction with each other to solve a series of problems. You can ask questions along the way. These 4 will distribute themselves, so please ask them questions as you get stuck. But we'll have an open Q&A towards the end as well if you have any lingering questions. But we'll hang around, right? If you have questions like, hey, is Amazon hiring? Where do I go? Which group do I need to apply at? What is AWS? Where should I? Whatever questions you want, we're happy to answer, right? We want to see you all grow, and that's why we keep coming back here. So we'll stay as long as you need us to answer any questions you have. And we'll share our contact information so you can come back and ask me questions. Okay, so with that, let me kick this off, and I'll try to keep this as quickly as possible to accommodate the rest of the workshop. So number 1 is for anyone that's been in AI for the last 2 years, continuously this is what we look like, right? There's new models, there's new techniques. Just when you think you've figured it out, something new comes up again. I'm like, oh man, I thought I figured this all out, right? And by the diffusion models that Dr. Ahmed was talking about, even though they're pretty popular for creating image and engineering designs, they've been reapplied right now. The number 1 paper at NeurIPS, which is a conference, was for language modeling. Normally, transformers are really good for language modeling and diffusion models for images. But now you're seeing diffusion models being applied for language, and they've done really well. So there's something new always coming up, all the time. And there's research like all over the place, right? Like there's thousands of papers never in human history has so much research being done on a topic. Never happened, right? So this is Archive, which is a place, a preprint server. Many of you must be familiar with it. It's a great place to go learn about what is really happening with AI. And if you don't know what's happening, download the paper, drop it into Claude or ChatGPT and ask questions, right? It's pretty amazing. And it's going to get worse because both the Nobel Prizes for last year went into people in AI, right? So Jeff Hinton and John Hopfield really came up with the idea for deep learning. And then on the right side is actually the original diffusion model that used diffusion to synthesize a protein, right? So if you thought AI is crazy right now, every researcher is looking at how do I use even the linkage problem that Dr. Ahmed was talking about. You can use ODEs, right? Essentially differential equation solvers, but using neural networks to solve those linkage problems, right? So it's pretty amazing, what you can do. Here's a quick demo of basically the work that won the Nobel Prize. This is the AlphaFold algorithm running inside the cloud, wherein I can take essentially an RNA sequence and go from that sequence and say, hey, I want to run essentially the AlphaFold algorithm, which is powered by diffusion style techniques, and then say, how would that protein look like if I built it up? And in a matter of maybe less than an hour or less, depending on how much compute you throw at it, you can effectively create thousands and thousands of proteins. And this is from a real customer who's applying this to do drug design, right? So nothing is theoretical. You have hundreds of companies and startups, applying these techniques to design these molecules. So the fundamental building blocks are important. Dr. Ahmed showed you how you can use neural networks to design physical products, right? But you're also seeing similarly diffusion models being used to, for biological products as well. And this is everywhere. So learning deep learning and learning transformers and diffusion are really going to be the building blocks. Do not leave this school till you do that. I highly, highly recommend it. It's math heavy, but it's absolutely worth it.
You don't have your.
Hey, someone can go on mute. Or Bruce, if you can use your superpower.
I just muted Vishal.
Okay. So if I had to zoom out and look at where AI started, where is it right now, where is it headed? This is at a high level how I look at it, right? So till 2022, AI was really good at predicting stuff. Find me fraud, find me bad stuff in manufacturing, find me using a variety of prediction algorithms, find me a bad part, so on and so forth. And it's not going to slow down. Prediction algorithms will be here forever and ever, right? But starting with 2023, since the early transformer days, AI started to become an assistive tool, right? How many of you go around at least one day without being assisted by AI? It's impossible nowadays, right? Even if you don't know it, you're doing it. So AI is really in the assistive phase right now. Late 2024, and certainly we are in the throes of 2025, it's not just assisting you anymore, it's going to do your job. This is the true power of agents, where you can ask it to do a little work for you. And depending on where AI truly goes, that's why I have a question mark there, and how far it might take, it's not just doing your work, it's coming up with completely new ideas. So even today, we have a bunch of scientists who are basically giving intractable problems, very similar to, again, the research that Dr. Ahmed said, like, hey, I want you to design this, and 87 students sat down and did it. What if you just give it to a bunch of AI agents? And the AI agents themselves thought through some of these ideas, and they're coming up with pioneering ways. We'll speak a little bit about early signs of that. It's, again, we don't know how far we are from it, but it'll happen soon, right? But when I speak with customers, they're excited about this vision, but at the same time, they want to make sure, and you should all think about this, is like, is this secure? Am I making sure my data is secure? Remember, data is the oil for AI. Second, is it being responsible? Especially if you apply for banking and healthcare scenarios, last thing you want is to do is an approve or disapprove a loan with an algorithm that is biased. That's not right? It's not good for anybody to go do that. Third, is it sustainable? If you've seen this, your power bills are going to go up, whether you like it or not. New Jersey, the state where I live, has already ramped up our power prices by 20%. Crazily, you know why? Because of AI. Because of all of you using AI, including me, by the way. We are all using so much AI, we're running out of power. So much so that we had to go buy. So Amazon invested in 3 nuclear powered centers, as in Microsoft, as in Google, right? All of us, we need power. So, but if you need to do this right, we need to be sustainable. We can't burn down the environment in our bid to become smarter, right? Or harnessing the machine to become smarter. And they go along together. Customers don't want to spend hundreds of millions of dollars. We have spent money, right? So Amazon alone has spent, by the end of this year, we'll spend almost $200 billion in AI expenditure, which is not small. But how do we make sure that we're truly getting the return on investment? And finally, how do we make sure that this thing is resilient? You'll see that today, when you hit these models, the throttling that'll come in, and you need to find ways by which you can stay resilient. So that's the ambition, but this is the reality, right? So how do you make sure that you realize that ambition, through the reality of what you see there? Just a few quick examples, right, for each of these. So I'll start with predict first. In manufacturing, and I'm keeping it my manufacturing, given that we started with the MIMO team, but you can see the similarities everywhere. So number one is prediction. So this visual end-to-end cycle is a very, very common one. You might have a factory where you have hundreds of devices. They connected via IoT or some kind of sensors that pull in that information, and then they take that information and they start to understand in the cloud like what is going on. And sometimes you could do synthetic data generation to augment it. Some of the things that Dr. Ahmed had alluded to as well, right? So how do you combine real-world data with synthetic data so you can create a larger data set? Because once you do that, now you can create software-defined versions of pretty much anything that never really had even software to begin with. Because the minute you can software-define something, you can create a digital version of it, and you can recreate your factory almost anywhere else. And now you can run a variety of simulations. What if suddenly the amount of products that come in doubled up? What will happen? How do I simulate my whole factory? What do I do? How do I optimize it, right? So you can run a series of optimization algorithms, and AI is being applied at every step in the cycle. And once you're happy with the optimization, you push this back in, right? And going back into the predictive side. So this is alive at hundreds of our customers today, hundreds, right? It's a very, very, very common pattern. And predictive AI has proven out to be very popular, especially the field of predictive maintenance. The last 2 years has been the rise of chatbots, assistive everywhere. To give you a rough example, how it works, it builds upon the idea from before, where I collect data from my OT system, my operational tech systems. These are systems that sit inside the factory. Once I bring the data in, I use predictive AI towards the left to find any bad patterns. But then you combine it with one more thing. You can combine it with a variety of your documentation, your troubleshooting guides. So normally in a factory, you pull up something, you're like, oh, something happened. Where do I go? I need to find a whole bunch of documentation. You need to find the right document. You need to read all the instructions. Now the document is automatically pulled in, tries to match together what the error is. And using AI assistance, you can bring the machine back up and running much, much, much quicker. So the last 2 years, we've deployed at least 100 of these at a variety of factories across the planet. It could be in the machine, it could be a Siemens or a Schneider PLC. or it could be on a mobile, it could be a computer, whatever it might be. But we've seen this to be a very popular pattern. Even more so because a lot of these manufacturing companies have very high churn. Could be an employee leaving. So now I'm a brand new employee and I don't know how to operate this machine, or I've been given a week-long training. And if something bad starts to happen, how do I get up and running? Right? So this is really helping even more so. In fact, the exact example of the customer is Toyota. And I love that name. They call it GearPal. It's something that comes in for the gear techs. This is an actual manufacturing location in the US, wherein GearPal is a generative AI powered tool that sits along every factory technician where they can immediately troubleshoot problems. And they've seen their mean time to repair come down rather dramatically. Now, if you want to hear more about this story, Bruce had mentioned the MIMO Symposium on May 6th. Show up for that. In fact, even bring your research there to even win award. So Cordell Franz, who is the lead, the AI lead, he runs a lot of AI projects at Toyota. He's going to be there to present the story. So you'll hear it directly, from them. And there's, as I mentioned, hundreds of these projects that we've done. It's pretty fascinating to hear that. The second thing, if I had to zoom out, a paper you can read today. This actually came out from MIT, I'd say 3 months ago. So for almost a year, MIT economists sat down with a very large material science company. I won't name who it is because the paper doesn't mention it. I happen to know who it is. And they said, hey, can I use AI to not just help me in my day-to-day, like how GearPal was, but design new materials, create new patterns, build more prototypes? And it turns out, absolutely you can. And the research, which was a very methodical research, walks through how they're able to create more materials, file more patents, not granted, of course, right, given the time frame it takes, and able to create lots of prototypes. And a lot of people wonder, what is so magical? Why is this happening right now? There's a couple of reasons why. There's a few things that make generative AI somewhat unique. If you've been in the AI space for any bit of time, right, if you look at the classic AI models, you need to bring in a lot of data. You need to do a lot of feature engineering on it to figure out what parts of the data is really valuable to you. You need to label it. You need to train your model, and then eventually deploy it. And this is how we used to do it for years and years, right? I mean, Amazon has been using AI for ages. And that takes a very long time to build these models. The power of generative AI, and there's pros and cons to it. They are pre-trained models, right? So they pick up a lot of information and you can get to recognition almost instantly. All you need is a prompt and you're off to the races. In fact, every time you interact with either ChatGPT or Claude or Grok or DeepSeek, whatever it is, effectively you're invoking a prompt to a model that's been pre-trained. So you're bypassing all these steps. Now you can do a basic prompt, maybe a couple of hours, couple of days. In fact, you'll build a bunch today. And then you can deploy a model or deploy an app with a little bit of testing, with evaluation in a few weeks, and you're off to the races, right? And this is why prototyping becomes really, really valuable and really fast, which is awesome, right? Because now I know some of you here, maybe quite a few here, are from a business background. And you're like, I don't know how to code, or I haven't spent as much time coding. I hate coding. Who likes to code? Anyone now can code. And you should. You absolutely should. There's no reason why you cannot code anymore. Because at the end of the day, the real power is with people who have the right business idea and have a business problem. You can say, I'm going to take my idea and I'm going to build something. So for example, now it's so happens I can code. It's a bad example for me, but for anyone else, right? Like, so I went to Claude and I said, and you can try this yourself. And I do a lot of presentations and I'm always learning about one thing. Can I finish it on time? I hate to be too early. I hate to be too late. I want it to be just right. So I said, can I build an app that tells me how long a talk might take? So I just went to Claude and say, hey, build me an app that gives me an estimate based on the talk, the number of words in it, and based on my speech rate. And it says, okay, no problem for you. And it builds me an app. And that took, and by the way, that's not even sped up. That's like live. All in takes 10 seconds, maybe. Produces the app on the right side. So if you're React savvy, JavaScript savvy, you can read it and understand it. But if you're a business person, you don't need to at all. It built my app right there. Now I can paste my talk and it'll tell me exactly, hey, I want to be brisk. I want to be relaxed. It shows me my approximate minutes and it shows me how many minutes it takes. Right? The app is simple, but the fact that I could do it in less than a minute and all it took was an idea means that any one of you all should be able to do this as well. right? And this is getting better and better and better, right? I built this maybe a couple of months ago, and these models are getting, and since then, 2 more models have come out, right? So these models are getting so good at this, so much so that Human Eval, which is a weird name, but is a software coding benchmark on how good these models can code. They never cracked the 20 barrier on a 0 to 20 till 3 years ago. We are right now sitting at 96. That's where we are. So now the benchmark, all these things, the benchmarks are being revisited right now to say, that's not a big enough benchmark anymore. We need a bigger benchmark or a better benchmark, right? So coding is completely changed. And we're seeing this again and again. So here's a customer again we saw where through the use of AI assistants, they're able to get significant improvement in their productivity. DoorDash, we all use DoorDash, and you may not know it. If you ever call DoorDash, especially if you're a DoorDash employee, they had to reduce the volume of calls was so high, they had to reduce the number of human intake that would happen to those calls. So now it's a series of like voice agents, and they've been able to reduce their money by $3 million per year, right? And design has completely been rethought. Dr. Fez showed some examples of in the manufacturing space, but the media space is completely taken over. So for example, I'm like, hey, there's a little device. I'd like to change the background. One little prompt and my background's changed. Right now I can put it in a fall setting, I can put it in a beat setting. And now if I'm in marketing or sales, I can hyper target my images. So I can say, hey, it's fall time. Maybe if I show this, will I get higher sales or not? But why do 2 when you can do 200, right? So now you can design hundreds of these. And by the way, it costs me all in 1 penny to create all of these images. 1 penny, right, of time. And maybe less than a minute to create all this. It's pretty amazing what you can do, with all these. You can get even more specific. You can go in and say, hey, look at this backpack. I see a little white flower there. Can you make that orange? These models are smart. It just didn't take that and that existing flower and paint orange on it and create a Frankenstein flower. It was smart enough to swap it with an orange flower that is a real species. Right? So again, pretty amazing what you can see. And the quality of these images, like look at that. That's a computer created image. And you never know that's a computer created image. And all I did, and I can't draw a straight line, right? I said, hey, here's the prompt, and I gave it a color palette, and it produces, right? So media is changing so much so that before the end of the first half of this year, you'll have a completely generative AI produced image, a produced movie on Netflix coming out from end to end, fully generative AI, from script to images to the video to the audio. So they're running that big experiment. Again, it's pretty amazing what you can do. And the last thing I'll show from an image standpoint is that image looks okay, right? It looks nice, makes you feel like drinking a cup of coffee. But what if you can make it a little bit more richer and say, I'd rather see that on the website. And that took, again, 1 second. All you're gonna go in and say, hey, make this image dynamic is all I said. And it knows every single element. It's like, oh, that's the sky, I need to move it. That's coffee, vapor, that's a wave. So it knows exactly the context as it creates it. In fact, the next time you go to Amazon and buy some products, 80% of the images in all likelihood are now completely AI updated, where they're not just produced by AI or at least enhanced by AI, right? And again, there's so many more examples we can go on and on. But the last one I'll leave with, I know it's not lunch yet, but that is, again, a completely AI generated image, right, from scratch, which for me is pretty amazing to see that. And these were created by the Amazon Nova model. They're pretty amazing for multimedia, image and video. And they're all built here in Boston. So the Amazon AI team predominantly is partly in Cambridge and partly in the Boston area. So the heart and brain of Amazon AI sits here. So you should certainly engage with us. Okay, so how did, I'll spend a few minutes on the evolution of the architecture behind, okay, you saw the front, what is happening behind, right? If you peel, take back the curtain, what exactly is happening behind some of these? So some of this will be slightly technical, but not that technical. If you think of most apps, they have a front end and they have a back end. I think this everyone knows. The app is where your logic is, and I'll keep it really simple. And this is where your data sits, and they communicate with each other using a variety of protocols, and you build your app, right? So most apps look like this. Now some apps can be a little bit more sophisticated where you break up this big model into smaller components. It's called microservices. And for the last, I'd say 5 years, there's been a big push to create these kind of service-based apps or microservice-based apps. And then for those customers that wanted to have predictive models baked in, they would insert predictive models so they can actually help customers with predict the next action if you're in banking, predict fraud if you're in credit cards, right? And so on and so forth, healthcare. And predictive models became really popular, as you mentioned before. You remember that, if you remember that evolution of AI. And of course, 2023 is when GenAI models took over, right? And customers would start usually with one GenAI model. GPT was the first one to move, and then since then we've got lots of models like Claude and others. The GPT was the first one. And the most common way enterprises would use it, and even you probably, is you basically say, look, the model is trapped in time. Most generative AI models are trapped in time. They're trained to a point, they only know that information. But if you want those models to understand your context, you feed in your context with providing your data, right? Anytime you ask a question, your app will suck in parts of your data and then combine it with a model and then spit out the answer. So you retrieve part of your data set, you combine it and augment it essentially with the prompt that you provide, and then generate and then have the model generate. So this pattern is called RAG. It's an extremely common pattern. But RAG is not easy at all. So in the last year, this is truly fairly cutting edge, is you need a variety of techniques to make RAG work really well. You need to figure out, how do I extract images, especially in manufacturing and engineering documents. You have small schematics, you have flowcharts. How do you understand all of those? You have deep engineering diagrams. How do you understand those? Sometimes the tables might span pages. The page setup may be different, right? You need to be able to understand all of that. So extracting it, then you need to chunk the data in many ways so you can give the model a chance to read it properly. Once you chunk it, you may want to store or extract information either from a structured data store like a standard relational database or maybe a knowledge graph. And then when you do the retrieval stuff, you're not only doing semantic search, you're doing keyword search as well. So you're combining a variety of search techniques as a part of the retrieval process. And then finally, you want to re-rank these results. So as these model context windows grow, if you've heard of the word context window for a model, and this year I didn't want to do a GenAI 101, but every model has a window of how much you can stuff into it for it to start reasoning about. And they've gotten bigger and bigger and bigger and bigger. But the problem is big context windows don't always help. You need to get your best content up front. So there's a series of re-ranking techniques that have come up to improve the quality of RAG. So every one of these techniques is now widely deployed in the last, I'd say, year or so, maybe even less than that. And this is the only way you can make RAG work. So if you're looking to build a RAG app and you thought it was easy, it is not. It takes a little bit of time to make it all work. And these are fairly state-of-the-art techniques. And by the way, the amount of research that gets applied. So re-ranking was the research that came up maybe 6 months ago, and now is it fully in production. I've never seen, and I was in research. I started my career at Bell Labs Research. We would do research and we would be sure that we would never see the light of day, right? Because it was like research to production was like years, if not decades. And now it's like weeks. And I'm like, what is going on? So all these were a research paper at some point, submitted maybe less than a year ago at ICML or Europe's one of these conferences. And just like that, they're sitting at a fully fleshed out implementation in production. I'd say early 2024 is when customers realize that one GenAI model is not enough because you have different use cases, right? Even transformer and diffusion for text to text, image to text, or text to image, you'll have a variety of models, right? So customers started to deploy at least 3 models. On an average inside the enterprise, you're sitting at 5 models right now. That's what we see within the enterprise, right? But the main reason why customers want to do that is you want to essentially balance this trio of how fast the model is, could be throughput or latency, how cheap is it, by measuring price, and how good is it using a variety of benchmarks. And benchmarks are complicated. We're doing a ton of work with a variety of universities, principally included, to find the right benchmarks for these models. Right? And there's a model that is really good at one task will suck at some of the tasks, just like us humans, right? I'm good at doing one thing. I'm really good at doing many other things, right? So you need to find the right model for the right thing, and you need to have the right perspective around this. So the state of the art there really has become, when you have so many models, how do you pick them? We started by providing some kind of an manual harness so humans could pick it, but turns out that is just not sustainable. So how do you solve the problem with AI? Guess what? With more AI. And you'll see this again and again and again, where now all of a sudden LLMs are being used as judges. So one LLM is like, hey, here's the answer. And another LLM is like, nope, that's not good, right? So now you have one LLM balancing and judging another LLM. And by the way, this was a research paper written in February of 2024. And now it's widely deployed everywhere. And you can search for it. LLM as a judge. I think it was presented at ICML, and now it's fully production. And then going forward a little bit more, as customers started to put these in production, and we all are starting to hit it, the volume has gone up, right? I mean, GPT alone has 300 million users, right? I mean, you went from 0 to 300 mil. DeepSeek went from 0 to 200 mil in 48 hours. So how do you manage all of this crazy scale and spike? So researchers have come up with a series of techniques. They cache your prompt, right? There's a variety of ways in which you can cache your prompt to get higher performance. They can optimize your prompt, because we are not good at prompting. I mean, the machines have a special way of speaking, but we speak in our own language. So you need to go from our language to their language, even though it's still English all along the way, but a better prompt. So guess what? There's another AI model that wakes up and says, that's a stupid question. Let me make it sound much better, right? So you go from a bad prompt to a model optimized prompt by using optimization. You can use prompt routing, where you can say, for this question, I'm going to pick that model because that will give me the best performance for the lowest cost. But this question, oh, that looks really hard. I should send it to the most expensive model, right? So you essentially use prompt routing to maximize your cost efficiency frontier. So that way you're getting the best bang for your buck. This is, again, all of these techniques are widely deployed, across a range of customers. And finally, model distillation, which we are starting to see, which is actually interesting. We're in a school setting wherein you take a large model like a teacher and then use a teacher to train a smaller model called a student model. So it's almost like packaging Dr. Bonning and Dr. Ahmed into a little model, right? You take the teacher, you basically take their learnings and say, maybe I can squeeze a smaller model. And you do that to get better performance, solving a very specific problem, right? Because you don't want a full model to solve all problems. Let's say you want a model that is really good at maybe manufacturing design. You basically can take, Dr. Ahmed as a teacher model and then build a smaller model that is focused just on that. Very, very common technique now, model distillation. Again, these are research techniques not too long ago, but they're really popular. Even more so in manufacturing when you need small models at the edge, because you can't put big models at the edge. These trillions of parameters are just not going to work right at the edge. So you need smaller models, right? So we've seen a lot of distillation happen. The next pattern we've seen, so you've seen, multiple GenAI models. There's been the rise of basically powered by distillation. Now people can create their own models, right? So we have a growing number of customers who've been designing their own models to focus on either a domain, manufacturing, or a task, maybe fraud analysis, right? So the way I see it, if I look at a typical enterprise, my visual, for most workflows, I think specialists, like either RAG optimize or fine-tuned or distill, will be able to solve the problem. But for the catch-all, you'll essentially use the more generalist models. It's again no different from assembling a team inside the enterprise, where you have a blend of specialists and generalists, and you want the right blend inside your team. If you have too many specialists, you'll never be able to solve big problems because you need them to be generalizing at various points in time. But if you're full of generalists only, then you cannot solve the problems of today, right? Because you need specialists to solve that. So you need this blend, and we are seeing now the average large enterprise roughly has 100 models, 4 generalists, and dozens of specialists deployed inside the enterprise, right? That's roughly how I see the enterprise shaping up. So as you walk into the workforce or already part of the workforce, ask some of these questions, figure out how can you get the most out of the generalist models, or how can you build essentially the specialist model, right? Inside your mind. The next thing we are seeing is as these models get out, is these models can say a lot of things, right? Hallucinations are good, as Dr. Ahmed said, when you're being creative. But if you're an airline providing customer support, you do not want to be creative. And that happened, right? So a Canadian airline customer chatbot decided to give completely wrong wrong advice to a customer, and they lost their flight because of that. And the customer sued, and they said, "Hey, you gave me wrong advice." And the airline, in their infinite wisdom, not too smart lawyers, was like, "Hey, AI is not a human, so we're not responsible for it." Guess what? They didn't win that lawsuit. It is a seminal lawsuit where the first time a company decided to use essentially humans are not AI kind of an argument and try to detach themselves, but that didn't play out well. So customers are really worried about their brand, right? I mean, every company has a brand, a persona, the way they speak. When you see an Apple ad, even if the word Apple doesn't show, you know exactly that's an Apple ad, right? You can just make it out. So for a lot of companies that care about their brand, their persona, they want to put guardrails around these models. And guardrails come in various shapes. You could, pick any model, you could say, "Hey, don't talk about this topic." Let's say you go to the Apple website and say, "What's the best phone?" And the response is like, "Buy an Android." Not so smart, right? You don't want to do that. So you want to block off topics, you want to block off words, you want to block off sensitive information coming out. So you can put a variety of filters. This is the number one way in which guardrails are deployed. Above that, you can do contextual grounding, which is if you're doing RAG, don't give me answers that fall out of the domain I've provided you, right? And we see these models try to get very creative sometimes. And you have to tell them, "Do not, I tell you, here's my information, answer only from this." And then the topmost is truly cutting edge, where we are applying symbolic techniques to solve some of these problems. And symbolic techniques are kind of unique. I want to go back to the history of AI. I did that the last time I was here, wherein when AI was formed, you had formal math-based AI and machine learning-based AI. And for the last N number of years, machine learning-based AI took over. Neural networks is kind of a machine learning or training-based AI. But formal math AI has survived and it has its own mini tribe, and it's seen a lot of success, but in very specific domains: software engineering, legal, contracts, etc. So at Amazon, at least, we spent a lot of time looking at both these domains. And we said, what if we could bring both of those together? So reasoning, which is, even though we'll speak a little bit about reasoning models and thinking models, but reasoning is deeply rooted in philosophy. Again, if you've not taken a philosophy class, it'll probably be the most important. Don't leave college without taking a philosophy class. Computer science and programming is important, but philosophy is 10x more important. So reasoning is a way by which we think. And automated reasoning is the way by which we can get these mathematical models to effectively generalize very specific things. So machine learning, for example, in fact, the diagram that Dr. Ahmed showed, right, which had the histogram, what you're trying to do is you're always trying to find a model that fits the data that you see. That's classic ML, is find the best curve that fits the data that's presented to you. But unfortunately, that doesn't work in some scenarios where you needed to be extremely precise. A squared plus B squared equals C squared in a Pythagoras theorem, like we know that from Pythagoras. It's not a maybe, right? It is what it is, right? So it's formal math. So effectively what you do with automated reasoning is you essentially use formal math to not just look at a subset of the data, like you do in classic machine learning. It'll apply to all the data. A squared plus B squared equals C squared applies to all the data. It's not like a subset of the data, right? So using that technique, right? So for example, what you could do is, let's say I'm looking at this page here, right? This is a page that speaks a little bit about zoning requirements for a dwelling. You're trying to buy a home, and essentially gives you the example of what zoning is. And what we want to show here is, I want to be able to chat with this page using this as a legal contract and say, "Hey, I want to build a home, but these are my rules that define when I can and when I cannot buy." There's no room for interpretation. You cannot hallucinate here, right? Because this is a legal regulation. So if I go to this chatbot and say, "Hey, chatbot, I live in Portland, so-and-so, the lot areas is, how many can I have on my site?" Now, for someone who's astute, can read the doc, understand the legalese, and come back and provide an answer. Now, in this case, we give it an LLM and say, "Hey, LLM, give me an answer." Now, the LLM gave an answer. This is for demos, right? And you can try this in real life. But then we'll apply a formal math almost immediately and say, "Guess what? This is not accurate," right? So once the answer comes out, you'll see that the formal symbolic side kicked in, and it says, "Nope, that's not the answer." And you can see how it was able to break down that dwelling contract we had into a formal mathematical language. And that's called SMT, which is the language that's used, statistical modular theory is what it's called. But you can break down legal contracts into mathematical statements, but combine the power of LLMs for natural language. Humans don't understand this. Humans understand natural language. So how do you combine the power of natural language with mathematical reasoning for a subset of the domain? This won't apply for everything. This won't apply when you're taking, a kid's doodle and trying to make it into a video. You don't want that, right? So she doesn't care about legal contracts there. But if you have a formal contract, you want to make sure they use techniques like this, right? And that's the combination of automated reasoning combined with this one. Okay, coming towards the end, we'll start to talk about agents and we'll think about thinking models, and then we'll go into the multi-agent part. But let's be very clear, AI agents have been around in AI since the beginning of time. Agents, in fact, were one of the building blocks of Alan Turing thought of agents when he created the first computer. The definition of an agent in the current age is very, very specific, where we use an LLM, a foundation model for its brain, for its thinking. You provide that LLM with a series of tools and data, actions that it can perform. Tools could be a variety of things. You provide it a memory, and you give it a persona. You bless it with something. Right? You anoint it a specific role. And in fact, you get a little more sophisticated, where you provide the LLM with a variety of thinking techniques. And again, this is where psychology comes in. There's a lot of applications where, hey, LLM, I want you to be a self-critic. I want you to apply chain of thought thinking. Think before you answer. You can apply tree of thoughts, right? There's a variety of techniques you can apply, for the LLM to think through. You can give each LLM a memory. In fact, today, are we giving them a memory or no? The default, okay. But you can give essentially an LLM a short or long-term memory, so it can remember long-running conversations, right? You can give an LLM access to a variety of APIs, so it can perform actions for you. You can give LLM access to your data, so you can do RAG, with it. It's called agentic RAG. And finally, give a persona, which includes giving it a goal. You are a customer care advisor. You're supposed to be helpful. People will ask you these questions. You're supposed to respond with this. In fact, you will build those today, right? So you'll create a series of personas, and essentially those personas direct the LLM to do something very special, just like us, right? Hey, be nice today. I mean, you should be nice every day, but be nice on this call, right? And it's essentially directing our brain, and this persona directs the LLM, along the path. And we've seen customers deploy not just one, but hundreds of these agents, right? Each of them performing various tasks. But today we'll do something even more advanced. And when I come back for the second time, I'll do a spot preview of where research is headed, in this space. And you'll actually build essentially many of these agents, as I mentioned, before. So that's the emergence of agents. A more recent emergence, I'd say this happened in the last month and a half, has been the rise of thinking or reasoning models. Now, the word reasoning is very complicated. There's a lot of curiosity to be like, oh, the machines can't think. Yes, they can't think like you and I do, thankfully, not yet, right? Or anytime soon, in my opinion. But they can still exhibit some behaviors of thinking. To give you an example, right? So for example, Anthropic, fairly well-known startup, in my opinion, way better than OpenAI, because of their deep understanding of what truly AI is. And if you don't follow Dario Amodei, who's the founder of Anthropic, you certainly should. He's definitely a really good thinker. And essentially, they built these thinking models. And to be very specific, what we say when we say thinking or reasoning model. If you look at the left side, is a classic LLM. You ask a question, the LLM gives you back an answer. Now, the reasoning LLM, now again, I want to be very clear. There is some thinking happening even with regular LLMs. It's not like they're not thinking. But the distinction with a reasoning LLM or a thinking LLM is you give it more time to think. It's just like going to a human and saying, hey, I want you to think a little bit more about this before you answer. And what do? Sometimes you say, what's the capital of Italy? You can come back with an answer fairly quickly. But on the other hand, if you're like, hey, if Italy decided to raise their tariff rate by 20%, what do you think is going to happen? Think before you answer. That is what this is, right? So you're applying computation, giving it time to think. And when you speak to the model, you effectively provide it more time to process that information and provide that information to you. So for example, where would you apply something like this, right? So let's say I'm doing a deep financial analysis. So I want a question wherein I want to say I'm doing an analysis on customer churn. There's a variety of factors I want to put in. Here are my factors: the number of customers coming in, their satisfaction rate, and blah blah blah. And you also provide a series of like, hey, I want to make sure you give me very clear scientific data and provide your deep reasoning and show me all your calculations. Your typical model can do this, but by giving it extra time, can actually answer more. And the best way to see this is to actually try it out. You can try this in 3 ways. You can go to Claude AI, click on Claude 3.7, and choose a thinking option. And when you do that, and you prompt the question, you can watch the machine think. It's almost like peering into a machine's brain and seeing how does it think. And that thinking is pretty fascinating. And by the way, I've spent hours and hours and hours watching it think where like it goes down a path, it pauses and says, wait, am I right? Should I be doing this? Maybe I'm wrong. Maybe let me pick a different path. And it'll retract itself and do something else. And then retract itself and do something else. So if you heard about all the DeepSeek mania that happened a month ago, DeepSeek R1 was the first open source thinking model that came up. So if you can go to deepseek.com, you can ask questions, you can click on thinking and watch as it thinks through, right? You can watch its reasoning. And you'll notice the quality of responses that come out of it are much, much, much higher. Okay, so hopefully that was fun. Before we go into the cognitive side and speak about other agents, I'll kick off the first workshop. You guys want to, Felix, you're picking it up? Yep. Yeah.
Thank you, Amit.
Yeah.
This was fun.